Some of the questions that I am receiving is hydrogen actually beneficial or not? What is the characteristics of hydrogen? Is it safe to be used in a motor vehicle or is it not? And for this, I will just do a quick feasibility study of the HHO generation onto a motor vehicle, internal combustion machines. And the first one that we will discuss is the auto-ignition temperature. With other words, auto-ignition temperature is where you compress the gas, where it will ignite instantaneously on its own without a spark or energy added in the form of an open flame or something like this to that gas. Hydrogen gas, 585 degrees Celsius, it will start to ignite on its own. Diesel fume is 210 and petrol fume is 245. Now if you look at diesel fume, a diesel is a compression ignition machine, a CI machine, and the 210 degrees will make sense to you because it must ignite on its own, and it will immediately tell you that 210 degrees is actually the truth, because you need a low temperature on diesel to ignite instantaneously, because as a diesel is a fuel, the diesel is sprayed into your chamber and is atomized as a gas. It will ignite very easy. Petrol fume on the other side, 245. You don't want the petrol to ignite before the spark plug can create a spark. So you need the petrol fume. 245 is making sense in this term, because you don't want a 210 degrees on the fuel, because the fuel will ignite before the spark plug has the opportunity to actually ignite the mixture. We also point to AFR. The AFR values is the air fuel ratio. Hydrogen, you need about 33.4 grams of air to 1 gram of hydrogen to actually have the best theoretical possible ratio between your air and your fuel. Diesel is 14.5 to 1 and the petrol is about 14.7 to 1. Hydrogen, if you look at the lower explosive limits of hydrogen, hydrogen can ignite from about 4% right up to 97%. So if I fill a room with hydrogen gas at 4%, it will still ignite. At 97%, the room filled with hydrogen gas, it will still ignite. So it's very favorable. Ignition temperature, this is if we apply a flame to the different gases, at what temperature will it ignite? Now, diesel is about 66 degrees. Everybody knows that diesel doesn't burn that easy. If you have 1 liter of diesel and you try to light it with a matchstick or even with a cigarette lighter, it's not that easy to get that diesel to ignite. Petrol, on the other hand, with a normal matchstick, a normal any flame of about 44 degrees will ignite the petrol. Hydrogen at room temperature with very little energy or very little effort, it will ignite. And in both petrol and hydrogen, a minimum energy spark of 20 millijoules is needed for ignition. That's a very, very tiny spark, very tiny amount of energy needed to ignite petrol and hydrogen. And one can understand why a gas station, a filling station, will always tell you not to use your cell phone while filling your vehicle. Because if there is any challenges with the earthing, and a potential difference exists between your car and the filling station, that a small little spark caused by your cell phone use can actually ignite. And this is why we also do not experiment, analyze, or build any HHO generators inside the home, because this gas is different. The oxyhydrogen gas is lighter than air, so it will go up and it will accumulate in your room, in your house. And a little spark, for example, caused by switching on or off of a light inside your home can cause an explosion. And this is why this ignition temperature is very important. Octane numbers. And diesel, we talk more about cetane, so we only compare the hydrogen to petrol. Now, hydrogen is about 130 and petrol is a 98. And this gives you an indication of the pre-detonation that can occur, the chance for pre-detonation, or what the most people call it, knocking off the engine. The hydrogen will not ignite that easily while it's during the compression stroke of your petrol machine, because you can see that it's 130, so it's much more stable. The petrol will ignite before the hydrogen. Now the flame temperature when it's ignited is also important. The petrol is 2197 degrees, the flame temperature when it's burning. Hydrogen is about 2045 degrees. It's basically the same flame temperature, it's not a much difference. But what is most different in 0.6 is the energy value. Hydrogen contains energy of about 120 to 142 megajoules per kg, while diesel is about 45.9 megajoules per kg, petrol is about 48 megajoules per kg, and biodiesel, it also depends on the type of biodiesel that we are using, but it's an average, it's about 42 megajoules per kg. But what is important here, that hydrogen contains, if you look at those figures, it contains about 3 times more energy than the equivalent of diesel, petrol, or biodiesel. The combustion data and the results is very important. Petrol machines, the mixture is more homogeneous because we got a compression stroke, and right in the beginning of the compression stroke we inject the petrol mixture inside the combustion chamber, and then we compress that mixture. So your petrol have actually ample time to move around the air molecules and to actually spread evenly through the combustion chamber. And when your spark plug at the top of your combustion stroke is igniting this mixture, it is right through, it's actually distributed right through your mixture, and it ignites very evenly. While a diesel machine we compress air and then we inject the diesel fuel at the top of the stroke. So your diesel there's no time for the diesel to actually mix properly with the air particles, and your diesel is more or less focused in the center of the combustion chamber. And you will understand that in both cases, because of the concentration of diesel is more in the middle with less air, it will result in about 30% of unburned fuel to escape the combustion chamber unburned, and will end up in your exhaust system and then will be exhausted. So it is not that 30%. It is actually horrible to think about it, that of all your money you're just burning 30% of your money of the fuel that you put into your vehicle. It is just going past without being used. The combustion flame approach distance is also very important in internal combustion machines. When we talk about combustion flame approach distance, as the mixture is ignited, the flame will approach your wall, your combustion chamber wall, and that is cooled by your water, and because of you losing the heat, and it's much colder on the combustion chamber wall, it actually distinguishes the flame. And the flame approach distance without HHO generation is about 2 to 4 millimeters. So if any fuel is accumulated in that distance, it will not burn. And that's a problem with all internal combustion machines. If you add hydrogen, oxyhydroxide gas, or even just hydrogen to your machine, your approach distance is about 0.2 to 0.4 millimeters. And with hydrogen fuel added to the vehicle, or oxyhydroxide generated by HHO generator, you got actually you can get actually closer to your combustion wall, and you can actually burn any fuel that is inside this area. So your volumetric efficiency increase of the engine, because you're actually burning a bigger effective volume. The addition of hydrogen to a normal fossil fuel, the normal carbon fuels, diesel and petrol, the flame speed of hydrogen increases the combustion flame speed between 1,000 and 1,200 times. And this is very important. You get a very quick flame speed, and that's what you need in an internal combustion machine, where you've got a very short time for the combustion process. A reduction of 40 to 80% in emissions is common when you add HHO generation to your car. And petrol control system, where you've got lambda control, oxy sensors inside your exhaust for emission control and for the control of your fuel mixtures in your machine. And a diesel machine, on the other hand, is more of MAP and MAF control. Your manifold absolute pressure and your mass airflow sensor. Some of them got both, some of them only got the one, and it's more of an open loop system, where a diesel machine measures the quantity of air going into the machine and then calculates according to his mapping how much fuel must I inject for that certain amount of air that went into the system. Now, petrol machines are fitted with catalytic converters in the exhaust systems, and diesels are making use of EGR and particle matter filters. And on a newer model of machines, 2020 onwards, you will also have SCRs fitted, your catalytic, selective catalytic reactions unit, to make sure that the emission is actually standards are achieved. Now, also important, your oxyhydroxide gases formed by HHO generator, because your oxygen is at the level of nearly 30%. Because of these gases, about 66% contains hydrogen gas, and about 33% is oxygen. Normal atmosphere, we only have about 20% oxygen in the air. So that increases your acceleration time from 20 to 30%. You increase your combustion process with nearly 8 to 12 times due to the oxygen content. Now, the special focus on combustion machine emissions, soot reduction, we can expect especially with a diesel, a reduction of 40 to 80%. With NOx, we can expect 8 to 15% reduction, and CO reduction is between 25 and 50%, and CO2 a reduction is about 40 to 60%. And I just want to show the Cummins machine, the KTA 38. This was an actual test that was run, and you can see they have achieved quite remarkable results. The actual soot reduction was 77.97, and if the expected value was 40 to 80, so that's perfect. The CO reduction was, the target was 25 to 50, they have achieved 25.77, that's remarkable. The NOx reduction, we expect normally from 8 to 15%, they have achieved 19.8%. And it's very important to understand that a diesel machine is a lean machine. It's got high gas exhaust temperatures, and the moment when you use HHO generation, you actually reduces your exhaust gas temperatures between 20 and 30 degrees. And because you're reducing by 20 to 30 degrees Celsius less, you actually reduces your NOx because NOx depends on your combustion temperature. The actual CO2 reduction that I received, this is not correct. I think that was 55%. We'll just verify this figure when I show at the end the actual machine. The actual O2 increase was about 14.6. Now we also need to understand, you will see that hydrogen gas is very favorable as an additive to your fuel. But the other question that always pops up is, how safe is it? Is it not a landmine that is waiting to explode any time? How dangerous is it? How can we control it? Now, one of the things that we got is a risk assessment, and a risk assessment must be done, what we call an RA. Now, during this risk assessment, we determine the hazards associated with the fitting of an HHO generator to your car. And we do specific focuses on the bubbler system, the control of the system, things that can go wrong. And then we look at the fuel cell, what can go wrong. We even look at the interconnection between the fuel cell and the bubbler cell. And we determine hazards. Hazards is the things that can go wrong, and we measure each one of those hazards in terms of probability, consequences, and the severity of the hazard. And we multiply those three factors together, and we then come up with a number that will indicate to us what, if it's significant risk, is it a real risk, is it a real threat, or is it just identified but it is not that important. What is very important then, after we have come up with all of these solutions, we're also looking at all of the significant factors, and we add mitigating factors then to the system. The question is, okay, we've measured the system, we know all of the hazards, we can identify all the significant risks, but what must be done to mitigate that circumstances, to make sure that the risk is acceptable or not acceptable. The second one that we then do is a FMICA. A FMICA is built onto your risk assessment. Your risk assessment is trying to focus on the hazards, and FMICA addresses this again by looking at each component to deal with how this cell, the fuel cell, or how the bubbler is going to fail, and how is the whole control system and the whole engine going to fail. And then we also look at the effects of the failure. Is there going to be a pre-warning of the failure? Is it going to be catastrophic disaster? How is it going to fail? How is it going to be indicated? And for each one of these components, we must put something in if it's significant, because it also looks at the criticality of each failure. And if it's critical, we need to actually do the proper engineering controls to make sure that we always stay in control and it does not create risk to the end user or to his vehicle or to the environment. Today, when we look at the control systems, the engineering controls, we've got pulse width modulation control systems that will ensure that the cell doesn't run away. In the past, we did not have any pulse width modulation, proper pulse width modulation. And it's very important to understand this thermal runaway. The electrolytic process is causing heat, and the heat of that process will increase your current. When your current increases, the electrolytic process will generate more heat. The more heat it creates, the more current it creates. And it's what we call a vicious circle that will actually end as a thermal runaway on your cell. But with pulse width modulation, it will control the current safely with no risk to the end user. Because with pulse width modulation, we can control the pulse width of the pulse, and we can control the duty cycle of the pulse to ensure that the current always stays in the limit. And it makes it easy for the end user if he have a 25 amp cell, a fuel cell fitted to his vehicle, to control it at 1 amp, 2 amp, 5 amp, 6 amp, or whatever the case might be. So this is the technology today. It does exist to actually control it safely. Today we also have the Faraday laws that describes the whole electrolysis process to produce the hydrogen gas. We don't have to guess this. We don't have to experiment with this. We don't have to reinvent the wheel. The sizing of the plates, the current selection for a certain car engine, capacity engine, is known. And we also know that the number of plates is known. It's a well-known fact that for a 12 volt battery, we use a 7 cell. And it's all based not on our own experiences, but it is all based on Michael Faraday's laws. Now we also know that the effective voltages per plate to ensure minimum heat generation must be between 1.2 to about 2.3 volts. And you will now understand why I'm saying that 7 cells must be used. Your motor vehicle can operate at about 14.2 when it's charging. So with 7 cells at 1.2 to 2.3 volts is perfect. Now also we have verification systems. We can measure the system if it's performing or not performing, and we can have objective results. We can use a gas analyzer to measure the emissions before and after to ensure that we're actually achieving anything with this addition of your HHO generation. The fuel economy is not is very easy to measure. We can keep a record of our fuel use versus before and after. So we can actually do this. Now I just want to explain my own experiences. Now there's various cells and different methods of building the cells, and it's done everywhere in the community right through the world, and excellent results were obtained by a lot of people and in terms of HHO generation. And your reported fuel saving is consistently between 12 and 35%. There are people that are achieving 50%, so the sky is the limit when it comes to this system. And it all comes back to the way you implement your knowledge and your skills to a specific vehicle. And it also depends on the condition of the vehicle. Now, what is important here, with a diesel machine, it's very easy to verify if your machine is in a good condition, because it's got a turbo that compresses the air, the exhaust system, your cooler, your intercooler, everything is under pressure. So with a little bit of a soapy solution, you can quickly verify if there's any leaks. With a petrol machine, much more difficult, because the petrol machine normally works on vacuum, and you don't want to use a soapy solution to determine leaks because you won't be able to see it. But with a petrol machine, what we normally do is we use a normal pipe, and we hold it next to our ear, and we listen for any sound of a rushing sound, a sucking sound, to determine if there's any leaks on the manifold or any of the piping. Now, about 30 years ago, I built my first fuel cell, and I installed it on a Tirana 2.7 turbo diesel. Now, during those years, I think people must realize 30 years ago, we still had our dial-up internet connection, and very little knowledge was shared on the net 30 years ago. It was very experimental at that stage, and there was a lot of negativity about HHO generator. During the last 30 years, I can see that a lot of it has been changed, and people are more open to suggestions. and would listen to HHO generation much more than 30 years ago. Now, at that time, when I built my cell, as an engineer, as a certified engineer, I believe in facts, and because of all this negativity that I have received, it changed my mindset to say that HHO generation is not worth it, and it cannot actually achieve what people are saying has been achieved. And I actually built my wet cell to prove my beliefs. And I didn't take care while I was building the cell. It was basically a slap together cell. I built it in one afternoon with what I had in the garage. And I wanted to put it in and experience it for myself, because I'm a very curious person, so I want to see what happens. Now, the cell that I built was about 4 amps, and I only used 4 cells because of the lack of experience and knowledge. I at that stage thought that this is perfect. I had no idea of Michael Faraday's laws. I didn't study it yet. I didn't understand what he was trying to prove. So today, when I look back, that fuel cell was too small. The plates was too little. I actually really had a bad design. But during this installation, I had no knowledge of SSR, pulse width modulation, and C++ programming. To me, it was not even concepts that was known to me 30 years ago. And microprocessor control was not part of my toolbox and my skill knowledge. The end result, I fitted it. I had a relay fitted in the vehicle. If I start the engine, the relay picks up. HHO generator was energized, and I was making gas, and I put it in the machine. And that was basically the whole scope and application of my project. Today, I realize that there is a certain risk involved as well. That you can have a kid or any other person can switch your vehicle on without starting the machine. An HHO generator will kick in and it will produce oxyhydrogen gas without the engine running. Today, with the risk assessment, I realize that you need another safety circuit to ensure that the vehicle is running. That's why we make use of an oil pressure signal, because if the engine is running, there will be oil pressure. We also connect it to the fuel pump, alternatively to the fuel pump. If the fuel pump is running, that machine is running. So even that, I didn't realize, and I didn't see it as a risk at that stage. Now, during the startup, when I had this little cell fitted to prove it's not working and to see what it can do, my first worry was when I started my diesel machine, my 2.7. The idle speeds fluctuated for a couple of seconds. It was hunting. It was obviously trying to set itself for this new change. But I didn't understand that, and to me it was actually a risk. And because I was not sure what the engine was doing, but I was young, I was unexperienced, and I didn't have the knowledge that I had today. Today I understand in full details what was happening. But I took the vehicle for a drive, and it was very careful. I was very concerned. My biggest concern was that after the explosion, after the combustion process, water is formed. And in my mind, I had this concern that water could stay inside the combustion chamber. And water is not compressible on a diesel, so it will destroy the vehicle. So I had this in my mind, and I went very slowly around the block, and I was driving around very slowly, just to make sure that no bad thing is going to happen to me. But immediately when I started off driving this vehicle, the one thing that will stay in my mind the first time that I operated on a HHO generator was that there was a smoother feel to the engine. And also what was strange to me, that the sound of the engine was a little bit different than before. And I could feel that there was a little bit more power, not a significant amount, but I could feel it as if the engine is more responsive. But I kept it in my vehicle, and I decided, well, I got it fitted, it is running. Let's see what happens. So it took me a while to get used to it and actually start to forget about this, because it was constantly in my mind that this thing is fitted. But during the months that followed, I started to realize that my petrol gauge, I'm getting more distance, because my petrol gauge was going down slower than before. But at that stage, I still had the doubt. Is this a good thing or a bad thing? And it still didn't make sense to me that this little unit can make a difference in the fuel economy. But at the one stage, I refilled my car, and I was staying at Ermelo at that stage. And I received quite a shock, because then I could see that there was actually a difference. Without the HHO, I achieved about 730 kilometers on a 72-liter tank. The 2.7 Nissan Terrano was not that fuel-wise. And actually, after I fitted it, I was reaching, and I could get to distances of 870 kilometers more. And I had this belief as then that I could achieve the 1,000 kilometers on a tank, which would be significant. But I was at that stage too scared to remove it, because with a fuel saving of 18%, before I only achieved about 10.2 kilometers a liter, 10.3 kilometers a liter on the 2.7. After the HHO generator was fitted, I achieved about 12.1 kilometers a liter. And to me, that was a significant. So I just kept running it, and I was happy with the 18% saving in fuel economy. To get 18 kilometers a liter, 18% saving in your fuel economy, and to use 18% less on your fuel economy, to me it was major. So I didn't want to fiddle with the vehicle. I just left it in. And also, I didn't have the knowledge to experiment with it more, because I really didn't know what I was doing. And today it's much easier to do. There's a wealth of information on the internet that people can use to build their own cell, or just to buy a kit and install it. But the one thing that annoyed me during that period, that I saw a lot of black patches on my garage floor due to water dripping out of the exhaust. And it was actually scary to see how much black stuff came out, the carbon in the soot that came out of my engine. And it took about 2 months for it to start to disappear. The one thing that I did notice, I was doing a lot of off-road during that period with my vehicle. And in off-road conditions, especially when the ambient temperature is 30 to 40 degrees, at one stage I went into Africa with that unit, and it was about 42 degrees, 43 degrees maximum that I achieved. And the Nissan 2.7 do not like to operate in that heat at slow speeds and high loads. So I made a lot of changes to my vehicle. I've installed a fan on the intercooler, and I fitted a thermostat switch onto the intercooler that will switch the cooling fan on and off, just to make sure that it's happy, that I can actually cool down the gases, especially with slow speed, high loads, when you go through the sand, through Chobe and places like that, that you don't overheat that vehicle. But what I noticed during some of the off-road trails with the HHO generator fitted, that I could hear that the fan was starting and stopping at certain intervals. So the machine was running cooler. But I never actually realized that. I didn't know at that stage that your HHO generator is also reducing your exhaust gas temperatures. And it was not a fact that was known to me. So I couldn't understand that 100% at that time, 30 years ago. But I noticed a lot of things. For example, when I'm cross-axle and I'm in low range first gear and I'm giving a little bit of speed just to go through, not speed but momentum, just to get through cross-axle situations, that the engine was more constant and more consistent and more smoother. I also noticed it when I'm in first gear, low range, and I'm going up inclines of 38-40 degrees, that the engine was more responsive. It was keeping the speed more consistent. And the one thing that I noticed, that I always had this challenge with the 2.7 on pull away. If I do a fast pull away, a black puff of smoke would be present. And with the fitment of the HHO generator, I had a little bit more power, but the black puff started to disappear. Now, a couple of guys, it was quite interesting. It was a topic that was discussed many times in details with my work colleagues. They were all concerned about this unit because the fear is always there. If you don't know something, you always have this fear of unknown. What is going to happen? And you tend to look more at the bad side of things than to look at the positive side of what the HHO generator is doing. And even what was strange to me, a lot of people, even if they see what I've done, they see the logbook, they still didn't believe it, because in their mind, if it's such a simple thing to do to achieve fuel economy, why is it not the standard in a vehicle? And that was a question that I came across a lot of times. And we had a lot of discussions on this. Now, 30 years ago, we had very little support on the fuel cell. We had dial-up internet. We had limited resources. We were operating in Windows 3.1 and Windows 95. And the systems, the computerized systems crashed more than information that I got from the internet. And most of the comments on the internet at that stage was so negative that I never took the time to actually research it more and to play with it. And I was too scared at that stage to lose my 18% saving in fuel economy. Because I had no knowledge to go further. Because to go further and to go to 20 and 25% and 30 and 35%, you need to have some sort of knowledge. You have to have the skills and both of the control of the cell, the construction of the cell, the chemical reaction that's taking place, and even you need to have automotive engineering and mechanical and electrical engineering to actually build the cell. Now, today, about a year later, after I fitted the cell, the real test came. I was towing a caravan to Winkelspruit for a holiday. On my return to Ermelo, I had all of those hill climbing episodes up to Pietermaritzburg. And I suddenly realized that this vehicle, for some reason at sea level, this vehicle was very responsive. I could feel the difference at sea level much more than I felt at higher altitudes. And on my way back, while I was climbing the hills, I was concerned about the exhaust gas temperatures, because this engine is now working. And it was not that hot. The ambient temperature was about 25, 27, if I can remember correctly. But I noticed that this Nissan is running past a lot of slower vehicles, also towing caravans. But it wasn't my concern that I'm overloading this machine, because I didn't understand exhaust gas temperatures in details like I understand it today. At Pietermaritzburg, I decided to stop, and I wanted the engine just to cool down and just to feel the exhaust gas temperatures, because I had no exhaust gas gauge in my vehicle at that stage, so I could not judge what is the effect on the exhaust gas temperatures. But what I did have is I had my oil pressure gauge and my boost pressure. I had those two gauges inside the car, and I could tell that the oil temperature remained an operating temperature, and it was actually to me that the engine is still fine. It is not overheating. But when I got to the top, I climb out, and normally I idle my vehicle for about 3 to 4 minutes just to cool down the turbo, cool down the oil, especially when I'm towing. But I idled for probably about 20 seconds. I let it idle. I climb out of the vehicle while it's idling, and I felt with my hand the exhaust gases coming out of the machine. And immediately I could feel that it was much, much cooler. And I could actually hold my hand there for a couple of seconds. And I let the machine idle for about 2 minutes, and it was normal operating temperature. And that is the moment where I realized that HHO is actually working. About just after that, I towed my caravan down to George. That was for a distance of 1,400 kilometers with the HHO generator fitted. And it was amazing for me to see the difference in fuel economy that I'm getting with this HHO generator fitted. And I had this vehicle probably for about, I'll say it was about a year and a half, 2 years later. I had the opportunity to replace the 2.7 of the 3 liter. That is more fuel economy wise than the 2.7. Because with the 3 liter in the Santarana, we get about 11 kilometers a liter. And it's got more power and more torque, which is suitable for off-road situations. And I replaced it, and I can remember when the buyer saw this unit on the car, he had no experience, he never heard about it. He was very curious about this, and at one stage I said to him, I will remove it, but after I showed him my fuel economy figures, it was a no-go. I had to leave it in the vehicle. Now, today I have the more skills and I have a more understanding of HHO. And you don't have to rediscover all of the faults that we made. Today you can buy a kit, you can install it. You don't need all of this technical expertise. You only need your expertise when you build yourself on your own. But it's easier today just to buy the cell, put it in, and learn how to use it as an end user and what is the dangers. Today, for example, I understand a little bit much more about the combustion process. I have the skills, both on pulse width modulation, but both in the programming of a microprocessor control. And my fears, based on my lack of knowledge, is today is more supported on a foundation of engineering skills and know-how. And I've realized today, for example, that cell, I could have achieved much more. But I was happy with the 18%, and today I hope I brought some of the characteristics of the hydrogen and the systems that is in place to make it safe. And I hope I did address some of the fears that people had. Please subscribe to this channel so I can bring more information. And if there's any questions, please do not hesitate to contact me. If you have any fears or misunderstanding, for example, a lot of people think it is dangerous when there's a small leak on your HHO generator. It's not. The moment when that oxyhydrogen gas leaks into the engine, it disperses so quickly and it dilutes itself so quickly because it's more heavier than air. it is not accumulating. And that's why the risk assessment addresses all of these issues. If we have, for example, that's why we fitted it more to the front of the vehicle so it can cool the cell. And it can be, if it leaks, it will leak more into the atmosphere, and there's a bigger chance for leaking in the atmosphere than under the bonnet. That's why I don't believe to fit this inside the motor vehicle. It must be fitted outside the vehicle. And it must be, and the biggest place that you got is under the wheel arch, or you got it on the bumper. There's enough space behind that bumper to have it. So guys, please, if you've got any questions or anything, please let me know. I would love to hear from you, and I will do my best to answer your questions. And thanks for taking the time to view this material. Thanks a lot.